biggest headaches, plastic waste. We're going to see how some incredible science is turning this environmental menace into a powerful resource for, you guessed it, energy storage technology. You know, our story kicks off with a sight that's become, well, depressingly familiar, hasn't it? Plastic bottles just clogging up our waterways and littering our beautiful landscapes. It's really the symbol of our global throwaway culture. And the sheer scale of this is just staggering. I mean, take Indonesia, for example. In just 1 year, the country generated 11.6 million tons of plastic waste. That's a number that's almost impossible to even wrap your head around. And a huge chunk of all that plastic ends up exactly where we don't want it, in our oceans. Look, this isn't just ugly to look at. It's a full-blown environmental crisis that's damaging ecosystems and threatening all kinds of marine life. But here's the stat that's really shocking, the one that tells you how bad we are at dealing with this. Globally, only a tiny fraction, just 9%, of all the plastic we've ever made has been recycled. The rest? Yeah, it's just sitting in landfills or floating around the world. So let's really try to grasp the global scale of this plastic problem, or as it's known in Indonesia, the masalah plastic global. Because honestly, the projections for the future are pretty alarming. If we keep going at our current pace, we're on track to have about 12 billion metric tons of plastic, choking our landfills and ecosystem by the year 2050. I mean, that is a legacy we just can't afford to leave behind. But, hold on. What if we could just flip the script on this? What if we're looking at this all wrong? What if all this waste wasn't really waste at all? What if it was actually a valuable, untapped resource just waiting for the right technology to come along? And this brings us to an incredible innovation that does exactly that. It turns this waste into treasure, tackling two massive problems at the same time: plastic pollution and our ever-growing need for better energy storage. So, get this. Scientists have figured out a really clever way to convert marine plastic waste, yeah, the same stuff they pull right out of the ocean, into a high-tech material called activated carbon. Now, this isn't your average charcoal, it's like a super material, engineered right down to the microscopic level. And this slide right here perfectly illustrates that incredible transformation. On the left, you see the chaotic, messy plastic waste we started with. And on the right, that's the result. A highly structured, super porous, and incredibly valuable material. It's a total metamorphosis. So how in the world is this even possible? I know, it kind of sounds like magic or maybe even alchemy, but it's pure science. So let's break down this amazing process step by step. Think of it like a 4-step recipe for making power. First, you collect marine plastic and give it a good wash to get rid of all the gunk, like sand and salt. Step 2 is activation. You mix the plastic with potassium hydroxide, or KOH. This stuff is key, because it helps create a really porous structure later on. Step 3 is where the magic happens, carbonization. You heat the mixture to a blistering 800 degrees Celsius in the nitrogen atmosphere, which basically burns off everything except carbon. Finally, wash and dry the result, crush it up, and you're left with this fine black powder that's just packed with potential. Okay, so you've got this fancy black powder made for ocean trash. What can it actually do? Well, this is where we get to the heart of the energy storage breakthrough. This activated carbon is the absolute perfect material for making electrodes for supercapacitors. Now, if you're wondering what that is, just think of a supercapacitor as the sprinter of the energy world, while a battery is more like a marathon runner. A battery holds a lot of energy and releases it slowly. A supercapacitor, on the other hand, can charge and discharge almost instantly, delivering these massive bursts of power right when you need it. And the secret sauce here, it's the absolutely insane surface area this process creates. We're talking nearly 2,400 square meters per gram. Now, to put that in perspective, a single gram, that's about the weight of a paperclip, of this powder has a surface area of about 9 tennis courts. It's basically a microscopic sponge for electricity. So, what does all that surface area get you? Well, it gets you performance. It achieves a high specific capacitance of 201 farads per gram. Now, a farad is just the unit we use to measure capacitance, so that number tells you how much charge you can store. And for material made from literal garbage, 201 is a fantastic result. You know, this single innovation, turning plastic into supercapacitors, is really part of a much, much bigger story. It's about the global shift towards a true circular economy, where absolutely nothing is wasted. And look, this is just one piece of the puzzle. Innovators all over the world are finding other amazing ways to give plastic a second life. We can melt it down to create fuel, mix it with sand to make building materials, break it down into useful industrial gases, or even turn it into filament for 3D printers. The possibilities are huge.
Ultimately, what this all points to is a huge shift in our mindset. We really have to stop seeing plastic as disposable garbage and start seeing it for what it could be, a valuable raw material for building our future. It's all about turning a waste stream into a value stream.
And that leaves us with one final big thought to chew on. With incredible innovations like this popping up, we really have to ask ourselves, is plastic waste truly a problem, or is it one of our most misunderstood and undervalued resources? The answer to that is going to shape the future of our planet.